All right, you're probably wondering if the chapter is called Log Functions, how this is going to connect to all the work we did with inverses in the last two videos. So today what we're going to do is we're going to start out by we're going to find, ooh, that's a cool color, find the inverse of an arbitrary log function. So I'm going to say that f of x equals log base b of x. All right, so that's my log function, and I want to find the inverse. So we remember from the first video there are three steps, and the first step is to write it in y equals. Perfect. Step 2 is to switch the x and the y. And step 3 is to simply get the y by itself. So we have to think about the last chapter and how we got a y that was an argument out of being the argument. Okay, and I'm hoping that a light bulb has just gone off for you and you're saying to yourself, why no, let's change it to exponential notation, or as we like to call it, what to the what equals what. So b is the base, x is the exponent, and now by simply changing it from log to exponential, I have the y by itself. Now I want you to be careful when you look at this and say that y equals b to the x is the inverse of y equals log base b of x, because we know that the definition of the log, when we change from log to exponential, would give us b to the y equals x. All right, so this is not the same. So it's a really tiny distinction, but this is the definition of this log, and this is the inverse. So f inverse of x is b to the x. Okay, so what this means is that anytime we have, let's see if I can move this down. There we go. Anytime we have a log function, we can quickly go to the inverse of it. So let's go ahead now and name a base. And so let's start as easy as possible, and let's look at log base 2 of x. And we want to graph it. We haven't done that before, by thinking about it being the inverse of 2 to the x. And I guess to have good notation here, I should say y equals is the inverse of y equals. All right, so that's the first thing you need to know. Well, we know this function really well. We've played around with it a lot. We always start out and by coming up with a few values, so we know that we can put in negative, positive, and 0 values, and we take 2 to those powers and we get 1/2, we get 1, 2, 4, and 8. So if this is the inverse of 2 to the x, right, then we know from the lesson in the first video that to find a table of values for the inverse, we simply switch the x and the y. So that's what I'm doing here, and then I want to talk about why it makes sense. So let's pick an arbitrary point here, right, and say that 4, 2 is on the function y equals log base 2 of x. And let's see how that makes sense. So we're saying when x equals 4, y equals 2, and we know that that's true. Okay, so let's go ahead and graph these two and see if we notice the same thing about the reflection across the line y equals x. So you're used to me saying if it's an exponential function and we're growing, that we can do a quick sketch that looks like this, right? And then of course, because we want to be exact, we want to put some points on here. So we know this is going to be 0, 1, and this is 1, 2, this is 2, 4, and this is negative 1, 1/2. And those are all the powers of 2. So if we were to graph these, what we end up getting is a graph that looks like that. And so instead of 0, 1, we have 1, 0. Instead of negative 1, 1/2, we have 1/2, negative 1. 1, 2 becomes 2, 1, and 2, 4 becomes 4, 2. And then if we were to go in and draw that 45-degree line, that line y equals x here, we can see that for log and exponent functions, the same is true, that the log function and the exponent function are truly inverses of each other. Okay, we need to talk about the domain and the range of the log function. We already know, so if y equals 2 to the x, we know that the domain is all real numbers. We sometimes write that with the big R with the double leg, or we write it interval notation like that. We know the range, that the value of y equals 0 doesn't exist, so we have a curvy bracket, and we say that the range goes from 0 to infinity, curvy brackets on both sides. Now here's an interesting thing about inverse functions, that not only do the x and y values switch, but the domain and range switch as well. And so if we're looking at y equals log base 2 of x, the domain now goes from 0 to infinity, and the range turns out to be all real numbers. Okay, and that works not just for log and exponent, but for any two functions who are inverses. The domain of the one function will be the range of the other function, and the same for the range. All right, does that make sense? Later on in your book, you're going to be transforming the log function, just like we did with the function 2 to the x. We moved it up, we moved it left, we moved it right, and we'll have some problems in class where we practice on transforming the log function as well. Okay, hopefully this video has been helpful. See you in class.